they ran until 2.5 times as many were necessary cross the finish line. I don't mean grammatical part here, but it's still okay. If 4,400 crossed the finish line, how many were necessary? So what do you think? I think since you've been solving equations now, wherever like a chance you can set up as an equation, I think you should. So this is actually should be one of them. Maybe some may not be as useful or good to set up because it's easier to do it another way. But what do you think about this one? The key phrase is necessary. You can treat the word necessary as like an object or a person or a noun or the actual thing you're trying to define, right? I don't know. What do you think?
2 and 1/2. You have to make the improper fraction.
Okay.
So 5 over.
Okay, 5/2.
And then
Here.
5/2 times 4,400 equals x.
Okay, not quite, because if you look at the last part right here, after the comma, right? How many were necessary? If you notice that it says 2.5 times as many as were necessary. You don't know the necessary. You don't know that particular. I guess you can think of it as an unknown. You don't know that. You see, if you're timing, okay, let me see how you saw that. I don't see it that way, but let me think. If 4,400 crossed the finish line, this is like the total number of people or objects, right? So therefore, your timing, if you time 2.5 times to that, you're bloating up that number. Think about it, right? More than they exist, or at least participated in the run, I guess, right? This is the run. Does that make sense? Think about it. If you times 2.5 to that, you now bloat up that number, the number of people. The way it's worded is not. It's limited to 44. That's the max number of people in participating. So you bloat it up. It won't make sense anymore because they ran 2.5 times as many were as many as were necessary. 2.5 times as many as were necessary crossed the finish line. So how many were necessary? You want to think about it again?
So is it 2 or 5/2 times x equals 4,400?
Yes, your x going to be that necessary, right? That word necessary that you're looking for. Is that okay? So yeah.
Yeah.
So you can go ahead and do 5/2 like you want it. I would do that for sure. Equals 4,400. Is that okay? That's it. Let's do the math here. Okay, multiply both sides by 5/2. 2 fifth reciprocal. So let's slash through. All right, 5 can go into, or you can multiply by 2 and then divide it by 5. I would always attempt to do it, but I think you can use the calculator here, right? By this time, yeah. I assume. Okay, let me see. But I would still recommend you practice the canceling for a habit, just in case it's not this big, right? For 4400 divided by 5, and then times that by 2. And like in the calculator, it's like, what is it going to matter, right? Yeah, so it's going to be 1760 people. So if you read into it, it should make sense, I guess. Like, it's still a little confusing to me a little, but the way they phrase here, I think there's some grammatical thing that could be changed here. 2.5 times as many were necessary. 2.5 times as necessary. If there this many for 4,400 crossed the finish line, how many were necessary? So that, to me, it's implied that 4,400 is maxed. So you can't blow that number up for an answer. That's all. Is that okay? So therefore, it's inside. It's the amount of people in that 440 that they're asking for. Yeah, time as were necessary. Yeah. Yeah, the story is a little confusing. I think that whoever wrote this tried to be fancy with the wording, but could have written something more, you know, under, I don't know, understandable. This is, yeah, that's why you were confused. I was a little bit myself. Anyway, let's continue. But I'm pretty sure this is correct because of the way, the nature of the, yeah, it's algebra. This one is actually, I'm pretty sure this is the answer, but just that making sense of what is going on. It's like some people don't understand what is happening there. You know, why is it necessary to cross the finish line? What I don't know, but yeah, but I'm sure of it because of the total. You cannot surpass that total. So therefore, that's the only thing that you can do. That's it. All right, let's see number 2. Thomas walked 12 miles in 4 hours. Okay. After a good night's sleep, he doubled that speed next day. How far did he travel in 7 hours the next day? Okay, what do you think? It's not too bad.
So you have to do 12 miles over 4 hours, and you have to reduce that to 3 miles per 3 miles per hour.
Yes, very good. So it's equal to 3 miles per hour. I'll, I'll write it. Okay, I'll write it this way: miles
3
per
miles over 1
hour.
hour.
Or don't forget, I can also flip that back into the fraction to use it, right? Okay, now
Yeah.
or
And
not,
then
or not. Okay, and then what?
you have to if it doubled, then it'll be 6 miles per hour.
Okay, 6 miles per hour. So times 2 here. I'll make a note of that. Okay, now you're getting this, right? You see the rate? Yeah, the unit will stay as is, right? You don't double the mile, you don't double the hour, right? Because of the way it's worded. Yeah. So you double the speed. Speed is miles per hour. Okay, now how do we continue? How far did he travel in 7 hours?
So then you have to do 6 miles over 1 hour times 7 hours and cross out the hours and then multiply 7 times 6.
That's it. Looks good to me. Very good. Yeah. By this time, you may not have to show this unit multiplier anymore, but I think you should still. Why? Because if you do move into science, right, like you're doing chemistry and things, this will be extremely, extremely helpful. It's going to be something that you're like, yeah, I get it, always get it, because I've done this like forever, you know. But yeah, we're going to times 7 hours, and like you said, we'll cross out that. It's really over 1, and then multiply what you have. So that's it. 42, is that right? 42 miles. That's it. Okay, looks good to me. Yeah, you got this down very well. All right, let me see. Complete the table. Let's do a little quickly. Okay, 81%. What is it? Move to decimal places over, like this, right? From the right, and remove the percent symbol, and then fraction. What's fraction?
81 over 100.
Yeah, it's not reducible, so therefore we'll leave it. Okay, 4. All right, let's do 4. the ratio of the number of tall people to the number of short people among the students was 5 to 13. So, right, I think we're going to do fraction here, right? We're going to do 5 tall to short. So I'll do T to S here. I'll make a note of that. If there were 105 tall students, how many short students were there? Okay, here again, this one, you could technically do this like a unit multiplier, but I think you should set it up as a proportion. Could you tell us a proportion problem? Yeah, I think you want to get used to doing exactly this from here on out because you have, I remember vividly you were doing proportion before based off some wordings too, I think, but earlier on, I think it was like geometry related, like, oh, like similar triangles. There you go. That's a proportion. Therefore, it is valid for you to actually use that concept from here on out. I think something that you would need because this wording, everyone used proportion. This type of wording, I'm not saying just at this class level, moving on in the future, they always set it up as a proportion because of the way it's worded. It may be a little different. It may not say ratio. It may just imply this to that, imply this to that, and therefore, what about that? What is going to be this, right? I mean, but I think you know what I'm saying. You'll know it. When you see one. I mean, I could technically make it up. But okay, how would you do this as a proportion? Let's do it as a proportion. So we got tall to small, tall on top, small on the bottom. How would you make an equation out of it?
So 5/13 times er it would be 13/5 times 105, and you cross out the tall.
Okay, now if you're doing that, you're doing unit multiplier. So we're gonna try to do an equation. We're gonna form an equation out of this. We're gonna make a proportion. So let me make an emphasis here.
Oh, so it would be 5/13 times x equals 105, and then you multiply by the reciprocal.
13 times x. Okay, let's do it differently. Now it's still kind of new to you, but I promise you're gonna catch on in like always. You're always gonna do exactly this. Have a look, okay? I think I've shown you this. I'm pretty sure I have. You want to make another fraction here. Proportion means like, hey, you equate two fractions, but one is unknown. Okay, I'll give you that. A proportion is basically two fractions. One side, it's a fraction. Another side of the equation is also another fraction. But one somewhere in the numerator denominator is it's what you're looking for. One variable, one is missing. Do you want to give it a shot? T tall on top, small on the bottom. Now it seems like something that your teacher may not have. Yeah, go for it.
5/13 equals 105/x.
That's it. Now, if you're hesitating a little, it seems like that implies to me that your teacher has not really be enforcing it, but he should if he hasn't already. Maybe what I believe is that he should have if he hasn't already. Because of the similar triangles. Remember, you remember how you said you set up your similar triangles like this? It looks something like this. Something, on one side match the other side, this and the other side. This is a proportion. That similar triangle tells me that you should be doing it for other type of problems, especially word problems, when you can. So this is one of them. And I think you'll see more of it. No, I know you'll see more of it always. Just, I'm sure. Okay, you'll know it, and I'll keep telling you. Hey, do you remember this? I'll later on I'll say, do you remember? This is a proportion, dude. We were talking about it. You'll see it a lot, and you see it more complicated than this. You have like x plus 5, 2x plus 5 right there instead of just x. That's later on, okay? But I'm just messing around here, or making it yeah more complicated for algebra 2, for example. All right, is that okay? This is it. This makes sense, I hope. This is how you always attempt to do it if you can. Okay, something like number 4. I believe there was one. I'll look back before we call it. All right, how do we continue?
It'll be 5x equals 13 times 105.
Yes, cross multiplied. Again, you could have done 13 over 5. That means you had to do x over 105, right? Yeah. Is that okay? Yeah, you could have done it differently. So I'm going to show the work here. Times 105. Now, check this out, okay? You don't have to do this. You can multiply them. That's what like maybe 100% of your classmate would do, but not when you have someone to point out something that you can speed. You can do things a little better. In my opinion, it's better. Divide both sides by 5 right away before you multiplying the 13 and 105. Why? Because the 105 as the factor, right, in the numerator can be divided by 5. It will help you work just in case you don't, you can't use the calculator. Yeah, then you have minimal work to do by hand. So there you go. I want to show all that. So 5 can go into 105 21 times. You have a minimal work now that you can do, in a or by hand. But anyway, we're back to calculator. So let's speed things up. But I think you get it, right? I think you get it. Okay. Most often it's like you're not having to use the calculator. Just go ahead and multiply a digit by 2 digit or whatever. It's not, yeah. Okay, so the answer should be, what was it? 273. Is that okay? Let me double check. Yeah. Thinking why would it be bigger? Because yeah, the proportion says 5 to 13. The smaller got to be bigger. Is that okay? The tall will be smaller. Number less. Let me read it carefully. Yes. So that's it. It looks good to me. Hey, think about it, okay? Try to actually set it up this way because this is how they always do it for this type of problems moving on. So I think you should start doing it now. Whether your teacher, I think your teacher will accept this. 100%. There's no way your teacher will not accept it because you were doing proportion for similar triangles, okay? Therefore, it is valid. You can do this now. I hope you're okay with that. All right, 5. Let's set it up, but we may not have to do it. Let's set it up and I'll let you finish it because I want to get to as many as we can, like number 10 right away. Okay, how do we set up number 5? 24%.
24%
Yeah. Of what number?
times x uh times
Okay.
x equals 578, and you have
Okay.
to divide both sides by 0.24.
That's it. Therefore, you might as well write 0.24x. Is that okay?
Yeah.
Equals to 578, and then divide both sides by that. Okay. Well, since you already mentioned the work, so might as well do it. 0.24. So we get, okay, so let me see. Does it say to round? Let me double check here. So we got a repeating decimal. What do you think about that? How would you write your answer? 4%.
2.0 2.408.3 with the bar on top.
Wait, say that again. You said 2.4?
Or
Yeah.
2408.3 with the bar on top.
Okay, that looks good to me. Yeah, that would be exact answer, or at least notation wise. Okay, let's write that down. Okay. Yeah, 2408. Right, I'm going over the work now. Okay, I'll let you write that down. I think you got it here, unless you didn't see that, but I think you did. All right. What about number 6? Let's set it up, and I'll let you finish the work. What decimal part of
X times 150 equals 95.
Yes, looks good. All right. Number 7, round this big 9-digit number to the nearest thousand and write the rounded number in scientific notation. Okay, what do you think? Nearest
Um,
thousand.
so you have to round it where the 5 is.
Okay. Okay. All right. Tell me what will be the number that is rounded? 371, 305. What?
306.
306. And what's the rest of it?
000.
Okay, that looks good to me. Nearest thousand. Yeah, thousand. Yeah. All right. And then let's write this as a scientific notation. 713.
So it'll be 3.713 times 10 to the
Wait, are you sure? Wait. You stop at 3.
oh
3.7.
306.
Okay, yeah, let's keep all of it. Let's keep all of it. I know it's an odd looking number, but in chemistry that is like common. This number is common times 10 to whatever power. This is very common. Okay, but yeah, well, what power would
10
that
to the
go to the? Sorry, say that again.
to the
And
8th power.
8th power. Yeah, let's count that. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, looks good to me. Very good. Good job. All right. Okay, what about this one? 3 1/2. I'm sorry, I got this. Yeah, 3 1/2. Of what number is that? 5 2/3.
So it's 3 1/2 times x equals 5 2/3, and then you make it improper and then multiply by the reciprocal.
Yeah, you got this. Yeah, yeah. Let's write this down for the setup and leave some space for you to finish. Okay, I think your number 9 is good, but let me write it out. 3 to the second power plus 2 to the third power. 3, okay, that's my 3, okay? Plus a root of, yeah, check this out, okay? Root of 16. Are you okay me writing this?
Yeah.
Why? What about A? Yeah, what about A?
Oh,
Do I put 2 here? Like between the wedge? What do you think? Oh, I'm sorry, cover some stuff up. So this is my 3, okay?
yeah. So it'll be 16. You don't have to put a 2
Okay,
because
well,
the square is already.
okay, good. You're okay with that notation, right? It's implied there's a 2 there, right? Moving on, like you saw cube root, you might be doing fourth root and beyond later on. But a 2 is so common. That's the reason, if you ever wonder why, it's because it's so common. Square rooting is more common than, cube root and so forth. They don't want to keep putting the 2 in there. They waste ink or you're writing too much. Okay, I think you're good here. Yeah, of course, don't forget to evaluate there. All right, number 10. Let's have a look. So this is what I was looking for. 2. Oh, look at that. I didn't realize this gesture. If I hold 2 fingers and I just like hold it on the surface of the iPad, it actually undo like slowly. Have a look. Look at that. You see that?
Yeah.
Wait, let me go back. It undo, well, pretty quickly, but it's still like faster than just wiping it. I didn't know that. Look at that. I didn't know that before. I've been using this app like for years, dude. Oh my gosh, there's so many. Oh, unless they actually, they updated it. I don't know. Yeah, I don't know that. I don't think so. I think I just didn't know it. I think I've always had it. Oh man, interesting. Okay, so 10. Find A, the perimeter, and B, the area of this figure. All right, let's do perimeter. What do you think? How would you do it? I'll write it like a P, capital P.
So it'll be 24 plus 16.
Good.
Like, yeah.
16 right here. Because, yeah, this is 8, that's 8. Very good. Plus
Plus 3.14 times 8.
3.14 times 8. Not quite. Are you sure you want to stop at 24 plus 16? I mean,
24 plus 16 plus 24.
okay, now the circumference. I think this is like something you always like kind of a little kind of slow. You get a little bit uncertainty. You have this uncertainty about the circumference. You want to tell me again? I won't write the formula. I like you to come up with it, or just tell me what to write. 3.14 what? Don't forget it's a
3.14
half a circle
times 8 divided by 2.
times 8 divided by 2. Okay, so that's not the circumference formula. I'll write it again.
Or 8 squared.
Not yet. That's area, dude. That's area. So I know this is like they look the same, but you have to have it down. Let's have a look again. You got two version, right? 2 pi, which is 3.14. I think your teacher still, having you replace that with, and the other version is pi times diameter. So this is the only two circumference. Anytime you square things, it's area. So here's the area, pi r squared.
3.14. 3.14 times 16.
Yes, but is that it? I assume you're
Divided by
using
2.
divided by 2. Yeah, divided by 2. Or you could have it in the front here. You can imagine that, right? You can do a half in the front there. It's fancy though, but it's actually what you would do more commonly in algebra 2 or algebra. You'll be doing a half of something instead of divided by 2. I know you still don't worry about that, yeah, but you do it by automatically. It's just something that they make you write a half of half all the time. But anyway, oh, yeah, this is okay. Divided by 2.
Yeah,
Okay,
and then
that's the
you
perimeter.
can cross out the 2 and the 16, so
Yes,
it'd be 3.1 times 8,
yes.
right?
So technically, you were right? You were saying that earlier, but don't forget, you have to actually like think about how does that turn into 8. You want to show that, right? So this is something that, just in case you your educated guess may not be right. How about that? You got to show that to prove it. Therefore, yeah, it is going to turn into 8. But yeah, okay, that would be done, right, for the perimeter. Let me double check. Yes, 3.4 for the circumference, diameter, and half it. Yeah, we cut that in half. You could have whatever you want. You don't have to have 16, by the way. You could even have the 3.14. You understand that, right? You could cross cancel there. But you cannot touch 16. When you cross cancel, you're only allowed to do a pair at a time. Like you can do a 2 to the 16 or 2 and 3.14. Half of 3.14 is 1.5, whatever, right? 7. You can do that too if you want. Yeah. So yeah, don't forget we're dividing. We're not reducing. Get it? Like we're dividing by 2. Therefore, you could divide that 3.14 decimal number in halves. But don't forget that's the rule. You're only allowed to divide a number at a time. You cannot pick both numbers to divide. Had it been added, I know I'm going off track here. Had this been added like this, then you have to do it in both of them. Let me see if you know this. I hope you do. I'm making this up, okay? Instead of multiplying here, right? If it's 3.14 plus 16 and you're dividing it by 2, normally you will be adding this together and then divide it by 2, right? The order operation. But the other math that you're allowed to do, you can divide 2 here, you divide 2 there, but you still have to add them together. Do you understand that? Now, I don't know if you're okay
Yeah.
with this. You may not have had enough practice doing this, but if it were a variable like x plus y, then you're forced to let's just say that 2x, you'll realize that you can simplify by dividing 2x by 2 and then leave it as y over 2 for the other one. Anyway, I just want to point that out because it's math. It's something that you can you can discern, you can tell the difference. You have to know the difference. That's why you're doing a pair at a time when you're multiplying, and then divide. Okay, that's, don't forget, whatever this is, in the unit, what is the unit here? Meters. Is that okay? Blank meters. All right, what about the area?
So it'll be 24 times 16 for the rectangle. And then 3.14 times 8 squared. So 8 times 8 is 3.14 times 64.
Okay, that looks good. 3.14 times 64, or 8 squared. Looks good to me. Yeah, you got this, dude. Actually, I want to parenthesize this now. Hey, trying to go along with my punctuation here. Is that okay? Parenthesize is 16 or 24 there when you multiply it. Write it like that. Don't do a dot. It looks like a decimal number, when I wrote it, 24.16. So that's why you kind of, think through about what you're showing, like, hey, multiplying what number and what, you got 3.14, blend it in there. So, yeah. So this is actually something could be extremely important later on when you punctuate it correctly, because your math can get very complicated. If you actually miss your decimal or you multiply it, it's done. The whole thing would be bad, right? Can you imagine? Yeah, you have long strings of work later on in the future. So practice your punctuation correctly. Your teacher probably don't even care. Your teacher may not even do exactly this, but trust me, this will save you later on. It will save your butt later on. Yeah. I don't believe your teacher will be like making a big deal about punctuation, because right now he's he's teaching you guys at this level and getting you guys by at this level. He's not. I don't think he's looking ahead, so he's not going to make a big deal of it like me. But yeah, this is the way I always operate. Okay, so all right, let's see, number 11. Let's set it up or talk about it. I think it's not that bad. Okay, Florence ran 9 laps in 88 seconds. Babe ran 16 laps in 134 seconds. Who ran faster? How would you do it?
So
You
you
got
do
one.
9 laps over 88 seconds.
Uh-huh.
And then you have to, and then you do 16 laps over 134 seconds.
Yes. I would
And
use a
then you have
calculator
to,
here. Yeah, you got this, right? Yeah, I would definitely use a calculator here to see what it and compare. So I'll do that right now. Second here. And I'll compare that to 16 laps. I'm capitalizing the laps here because it looks like a 1. You see, look, every little thing, I want to make sure that, when you write, yeah, it's not going to, you know, confuse you, right? When you show handwriting, dude. So I've experienced that myself. So that's easy. Okay, so let's see in the calculator. 16, 134. Yeah, that looks good to me. Let's see what it looks like. 9 divided by 88. So we got a point. I'll round it to 2 decimal places. It shouldn't be that bad. In chemistry, you may have to round to 4. The number that you're comparing may be so close to each other. It's just the way they always kind of do it. So it's going to be 0.10. Man, I hope I don't have to continue rounding. I mean, come back to it. 0.10 for that one. And the other one, we do 16 divided by 134. So it's 0.11. Wait, can I do a 1, 2 on that one? I didn't see it. Yeah, 1, 2. Is that okay? Do you see it? So 0.12 here.
yeah.
Okay, so it's basically lap per second. Lap, if you want to kind of make sense of the unit, I'll do L per second. L per second, capital L per second. So now, let's make sense of it. Who ran faster?
Florence.
Florence. laps per second. Run faster. Are you sure? Who ran faster? We got Florence. We got Babe. Who ran faster? Okay, if you're not sure, okay, do you want to think about it? If you're not sure, we can make an analogy, like compared to like the speed on the freeway. Is that okay? For example, 60 miles per hour is it's slower than 70 miles per hour. Okay, I'll say it the other way. 70 miles per hour is faster than 60 miles per hour. Okay, so this is about speed. And the speed is always like the distance over time, like lap. Lap is distance over time. Lap is distance over time. Lap is actually, yeah, it's actually it's still distance, but it's the number of laps. Number of laps. Sure, because the laps are the same length. So we got, yeah, okay. I won't say it, but do you want to think about the answer again? Which one is faster?
16 laps in 134 seconds.
Yes. So it should be Babe. What we want to answer, like you already showed the work, so you just state the name. Is that okay? Like Babe, right?
Yeah.
Yeah. So Babe would be the answer. Do you see how I analogize that, like to like the speed, like things that you see in real life? Yeah. So it got to be the bigger number, the 0.12. It's by a little bit, but it's still faster. There's more laps. Okay, more laps in a second. More lap in a second, right? A little more lap in a second, in 1 second. So that's kind of odd, though. I don't understand why they made up this thing. So they made up so when you do the math and the number pop out, the number does not make sense. It doesn't look like, but in science, it doesn't matter. It makes sense to scientists. These two number 0.10 lap per second, the brain of scientists will be able to actually like see the reduced form of it and accept it. It's just something that, hey, it can happen in nature easily like that. So the number doesn't it's how big, how small. That's all they care about. The unit they can deal with. I mean, I'm not like that fully scientific like them, right? But I get it. Okay, yeah, pretty sure the answer's got to be Babe. So Babe ran faster. All right. All right. The rest, I think you're pretty good. I'm pretty sure. But let me look at, the order operation, the simplifying there. I'm pretty sure you're good. You always have to do them, right? You have to finish them. You have to turn them in. So yeah, I'm glad because this is great practice that you have to continue doing because you got the benefit here, dude. I told you my other student don't have this. They don't have it. They just like when they actually having to deal with this again, they're like slow down tremendously. Can you imagine that? They slow down tremendously. That's not too bad, but like something like this, they slow down right away. They're like, what? But you're getting the practice. All right, 20. Let's look at 20 at least. Let's talk about it. I think it's a little tricky. Okay, it writes solid and it's base. Okay, it could be the top to the right here. This is going to be the base. If the solid is 3 feet high, I would already label that. What is the volume of the solid in cubic feet? Okay, the dimensions of the base are in feet. Okay, everything's in feet. Yeah, so they're actually giving you the detail just in case. I have a feeling later on in the future they're probably going to make it so that you convert the units so they're consistent. Get it? Like in the end, it'll be the same cubic something. So the way, yeah, I don't know that, but it's just like they're being very detailed here. Okay, all the angles are right. Okay, I guess let's gathering the information here. I won't have to write. Let's see, 9 plus 4. Wait, what are we trying to do here? We're okay. Okay, that is not what we should be doing. Why are we adding? It's not asking for the perimeter. It's asking only for the volume. So what do you think? What do you think we should do? Cut them up? What do you think?
Yeah.
So cut them up here. I think that's good right there. I think. Okay, I don't know. Maybe here or maybe here. What do you think? I think most of you guys will go here for sure.
Yeah.
And what? If you want to be fancy, you can probably do it there. I'm not kidding, dude. You want to show off. Yeah, I don't know if you care for that. Why? You can do trapezoid there. Could you imagine, right? You can do two trapezoids there. One is kind of tilted up. If you cut this up, right, you can do a trapezoid like the way it looks right now. But this one on the bottom, you can tilt it a little bit like this. It will look something like this. Like that. For the bottom one here. And you trapezoid. Yeah, some student may want to show off that. Yeah, I don't know that for sure in your class. In your class, maybe there's some smart ass students in there. No, I don't know. Okay, what do you think? If you were to cut it here, would that better? It would be better than here.
Yeah.
Where? This
Up.
up like this?
Yeah.
You think? Okay, let me see. We got 4 there. Therefore, this better be 2, right? No,
Yeah.
wait, wait, wait. I don't know that. Sorry. So let's do the math here. Since we'll force this three rectangles. Okay, this is gonna be 16 times 9. I'll dot it. I'm parenthesizing this now. 16 times 9 for that. What about this one here? Plus 4 times something for sure. 4.
4 times.
Actually, 4 is actually this. Okay. Times what?
Wait. 3.
Why? Are you saying this is 3?
Because
Okay, this is what I see. 4 is this long. Look at, so I see that being 4 right there. See it?
Well, it's
4.
because of the top is 9 and here's 12. So if you're dividing it, there is even. So you have to do 12 minus 9, which is 3.
So wait, are you saying 3 is right here?
Or
Or are you saying
no,
3 is right here?
no.
Let me see. What about over here even, right? What about over here?
Oh
So
wait, if the side is 16 and 5 plus 4 is 9, then 16 minus 9.
16 minus 9.
So it would
16
be
minus
6.
9. It'll be 6 right here. All right, let's see.
Yeah.
Well, it seems like this is 5 to me right there, right? Do you agree that this being 5, this being 5 right here? Oh, what I mean is
Yeah.
like right here. If I add this up, it's not 16, it's 15. See that? If I add these up, I'm not getting 16 here. So I know this is 9 here. I think we're done with this triangle here, rectangle here. But these two over here, it's a little fancy. This one, let's do that one first. I'll bet you can get that one easy.
It'll be
Okay, I have a better way.
12
Right here?
times. Yeah, 12 right there.
Okay, good. Okay, check this out. I think they're trying to trick you here. So I have a better way to do this. I think we're making it too complicated. Check it out. Now, I'll bet you can do this. You still can like ponder over it. I'll bet you can do it. Like break it up, and double check it and make sure that everything works. But check this out. This is how I would have done it. Have a look, okay? I think they're intended to be done this way. I don't know that 100%, but I have a feeling. I have a feeling they want you to actually do this rectangle and this square, and then you subtract this off. See that? Get it? That you do a rectangle right here, and then do a square here, and then subtract this little gap right here out. Why? Because you know this one is 12. Therefore, you can do a 12 times 12 to get this whole thing, right? So let's have a look. So I'll be doing something like this. For this whole thing, it'll be just this part. Okay, let me make it correct. So it'll be, I'm doing this right now, okay? This right here. So it will be this right here, this portion. It'll be 12 times 12 minus 4 times 5. Do you agree? And then this one in front is just 16 times 9 or 9 times 16. There you go. You get it?
Yeah.
Yeah. So I think they're intended to be, so they they made this like a puzzle, right? It's like a game you're trying to solve. So I have a feeling this is exactly what they were doing. Because if you're trying to find like the little gap here and there, it might not be as quick or it might not be as practical. So I'm pretty sure this is what they're doing it. So yeah, so I see it, like I look out and I see it because we know this is 12 for sure, right? Is that okay? Because this is 4 right here. You cut it 4 all the way out there. Therefore, the remaining here will be 12. Therefore, this is 12, right? So
Yeah.
that's why. Okay, so this is it. You can copy this down, and I think this is the like. I have a feeling this is the actual work that they have like in the solution guide. I'm pretty sure. All right. Oh, and once you get that right, what do you do? We're doing volume here.
3.
We times it by 3, right?
Yeah.
So volume in the end, you'll take that number, whatever that is, times 3. Times 3. I'll do a dot here to emphasize it and even parenthesize it. So get that answer from up there, times that by 3, and that will give you the cubic, whatever feet. So whatever the answer is, cubic feet. Is that okay?
Yeah.
All right.